Hi student, today's session is on basics of physics, like how to start learning of physics starting from class 8, maybe in ICSC board or CBSC board. Okay, so for physics, the very basic things I'll explain now. First of all, you have to understand what is motion. Now, what is motion means, then what is not in motion, like object at rest. If object at rest, if anything which is not moving, we are considering it is at rest. Object at rest. If object is moving means object is changing the position with respect to some coordinates or some surroundings. So it will be in motion. Now something in motion means what happened? We know that the object will get a speed or velocity. Now speed means what? Position changing, like distance by time, and velocity is displacement by time. So here we are starting the the motion part of physics. Now whenever there is a motion, we will be getting the kinetic energy. And what is the formula of kinetic energy? Half mv square. So if something is goes to rest, after the motion, then what happens? That kinetic energy will be reducing and it will goes to zero. Then what about the energy? It will convert to other energy, right? So normally whenever you are considering the mechanical energy, we are saying about the kinetic energy and the potential energy, right? So initially starting from class 8, 9 or in 10 also, your first part of the chapter of the books will be the motion, So maybe it will be more elastic in 8 to 9 and 9 to 10. So motion is of two type. This is horizontal and this is vertical. So this is horizontal motion and this is the vertical motion. Okay. So now motion is, someone is driving the motion. Nothing is free in motion. Okay. So something need to drive the motion. Let's say, think of the football ground. What happened that the footballers are, constantly hitting the balls by their legs, right? So that means it's a kind of force they are applying consistently on the ball. So when there someone is, the forward player applying force and increasing the velocity, and some people in the, those who are, opposite end, they are trying to save the ball. They are trying to stop the ball. Okay, that means they are also giving the force, but they are, reducing the velocity, right? So by applying force, it will cause motion, and it may cause increase in motion, increase in velocity, and it may cause decrease in velocity. Those is whole things you can, you can able to observe in any football match. So if you see any football match, maybe in online for 5 minutes, if you closely observe the ball, so it will move around the ground by application of forces. And sometimes you'll see that the goalkeeper catch the ball. That means what happened? So goalkeeper catch the ball by applying a opposite force, opposite to the motion, and the moment he catch, the velocity goes zero. So kinetic energy goes zero, because kinetic energy means half mv square. If velocity is zero, kinetic energy is zero, right? So this way you can correlate the things. So correlation is very important, for your good learning or fundamental learning in physics. So this is about the horizontal motion I discussed. Now vertical motion. So for vertical motion, we can take the reference of cricket match. In cricket, whenever there is an, something is going to six or the boundary, on, players are getting, catch out, right? What happened? That batsman is hitting the ball, it goes up, right? Goes up in all time. You see that ball goes to certain height, then it is coming down. If it is going to out of boundary or inside the boundary, right? So why there is a limitation? If you see in cricket, you have seen that, the maximum, length in the height of the ball is, 100 meter, 110 meter, and maximum 120 meter. So far you have seen. So why it is not more than 120 meter? Because whoever is hitting the ball is going up, vertical motion. But the same time, the earth is pulling the ball by gravity. Earth is pulling the ball by gravity, right? So there will always be a downward force acting on the ball and upward force given by the batsman. So these two forces are acting, and certain time whenever there is in vertical motion, it is fully governed by the acceleration due to gravity. So ball is going up, and also the gravity is trying to pulling it up. So its velocity getting reduced, and in certain height its velocity will be zero, because there is an retardation acting due to earth gravitational force. And the moment it will be zero, again it will come down by free fall, again earth gravitation. This time earth gravitation will cause positive acceleration. The ball is coming right, coming down. Then maybe in someone taking the catch, or it is goes out of the boundary, right? So this, the physics is behind is the earth gravitation, and initially the ball kicked off by the batsman, and before that the ball was ball was thrown by a bowler. So just think on it, what happened actually when a cricketer is throwing the ball. Initially the ball was at rest in the hand of the cricketers. Now this ball is goes with a motion, right? Maybe 100 kilometer per hour, maybe 20 kilometer per hour. If you see the speed, right? Then this ball, once the ball is in motion, this cricket ball having its mass and also having it's at a velocity. So mass and velocity produce a new property called momentum. Momentum is the product of mass and velocity of an object. So you get this data momentum. Now with the certain momentum, it is goes to the batsman bat end, right? The moment it's in touch the bat, that time the batsman is hitting, right? So its momentum getting changed because ball direction getting changed. So velocity, value of velocity getting changed, so momentum getting changed. So now I can understand that this change of momentum caused due to the force applied by the batsman, right? So we are reaching to Newton's second law. Now we are in Newton's second law. So Newton's second law told that any change of momentum will be caused by the application of force, or in formal way, rate of change of momentum is proportional to the force applied on it, and this change in momentum will be in the direction of the application of force. If the batsman is hitting the ball like this, the ball will go like this in most cases. There are some exception, right? It goes to the third man or slip. So that's due to the momentum of the ball coming to it, and by how it is hitting the the ball is hitting by the bat, right? If it is straight bat, it will go opposite direction mostly, right? Okay, so now again we came back to Newton's second law. So and what about the Newton's first law? Newton's first law is that if something is in rest, it will be at rest. Let's say ball is in cricket ground. The cricket has not started. So what happened? That it will be in rest unless until some bowler is picking the ball and throwing toward the batsman. Again, so again the ball is in motion in the cricket floor, right? Cricket field. So if someone is not touching the ball, it will go on and it will hit the end of the ground. So that means we can see that unless we are not applying any force to stop the ball, it will go on. So it's explaining the Newton's first law. If an object is at rest or in uniform motion, they will try to continue that until someone is applying a force to stop the motion or make it move. Now, so this is about the Newton's first law. The Newton's first law, there is one keyword, inertia. The word is inertia. So what does it mean, the inertia? Inertia means it's a tendency of an object to stay on the current status. If a book in your library staying in a rest, so it will continue to be at rest unless until someone is picking up the book. And also, so that's the rest inertia. So inertia supported by the rest status, and other was in the motion inertia, right? Something is in motion, let's say cricket ball or football in motion. If someone is not touching the ball, it will continue the motion. So that's called motion inertia. Okay. So there are other some deep thoughts, for the higher classes. I'll be saying those in the other lectures. Okay. See, this lecture for those who already gone through the chapters, maybe 8, 9, 10, right? And now they are trying to assemble the concept. See, because whatever you're reading the chapters, right, you have to assemble the things in your mind. Okay, so that's very important. Don't go for any ordinary study. Go for 2 or 3 times normal study, then try to recall everything in your memory. So you take some real life examples and like cricket or football, and observe how the force is applied, how the force is working, how the motion is working, how the energy is working. Okay, now I'll give you one more example. You know that work. What is the relation between work and energy and mechanical energy? So work is equivalent to the energy, right? That means work, if so, let's say if I am picking up something from this height to that height, okay, I am picking something from this height to that height, so I am doing work against the earth gravity. So at this point, if I am having an object, it is having the downward force F is equal to weight, right, weight of the object. So I am I'm taking something in height h, that means I am doing work, and once I did some work, this work will be stored as an potential energy at these positions, So work stored as a potential energy. The moment I release it, it will come down and it will receive a velocity and also a kinetic energy. So work is again this potential energy converted to kinetic energy. In class 10, starting from 8 somewhere, and mostly in 10 it is an extensive that prove that the total mechanical energy is conserved in a vertical motion of an object, or maybe in a free fall. Object is throwing up or object is free fall. Both the way we can prove that total mechanical energy is conserved. So what is happening whenever I am throwing the ball? Initially it's have some velocity, having the kinetic energy, and in the maximum height reach, the total kinetic energy converted to potential energy. Again, if I make it free fall, this will come down here with some velocity. So total potential energy converted to kinetic energy. So this is about the energy and work relation. Now in your class 10 and also class 11, maybe mostly high extensive way, we will be studying the work energy theorem. So work and energy is equivalent. Okay, like whenever a goalkeeper is trying to stop a ball, so it's trying to altering the velocity, the goalkeeper is doing some work. So this work is changing the kinetic energy. Okay, so this way I'll come in some with other stuff in the next lecture. Okay, so thank you for today. So wait, wait and watch for my next sessions. Okay, and please reach me for any kind of doubts. Okay, thank you.